Good morning, ladies and gentlemen. My name is Koegelenberg. This is my second term at Automation and Training Facility, and this is my design project for discovering the world of Arduinos. Now, around a month ago, I woke up in the middle of the night feeling short of breath and came to the realization that I had left a paraffin lamp on I had used for lighting during load shedding. Now, instantly I had to run for a window because I could have killed myself very likely if I didn't wake up. Now, if only I had a sensor that would have warned me that I actually had left the lamp on. So I guess you could say my motivation is my own stupidity. Now, for my problem statement, it is to make use of heat and gas sensors using the ESP's mesh network capabilities to cover a large area and identify if there is a fire risk, and notify the fire department in the case that there might be a fire risk or carbon monoxide poisoning. Now, informal settlements are a big fire hazard, and that is why I chose this to configure it to be best suit informal settlements. Now, they are a big fire hazard due to them not following the municipality assigned build lines that are set in place to prevent houses from spreading fires from one to another. Therefore, if one house would catch fire, then very likely and very quickly a lot of houses could catch fire. So for this, the device would need to be reliable, low cost, and use low energy. Now, for the background, the traditional smoke sensor has been around since the 1930s, when a Swiss physicist, Walter Jaeger, has failed to create a toxic gas sensor, but in the end failed successfully creating the humble smoke sensor. Now, the use of smoke detectors, according to the US National Fire Prevention Agency, has cut the deaths per 100 fires from 1.8 to 0.53. That's almost cut in half. Now, for existing designs, it is a common exercise in Arduino tutorials to create yourself air quality sensor using MQ sensors that are gas detection sensors, and also heat sensors like the one I use. Now, existing Wi-Fi detectors, they do exist. They are somewhat low cost, but they do not cover a large area or are advertised using mesh network capabilities to be able to speak to each other. Now, what is a mesh network? A mesh network acts like a spider web of devices that is in itself self-healing and self-configuring. Therefore, if you do have a mesh network, you can always add more, and it will by itself configure it so that communication is possible. No extra programming needed. And also, something to note is that these ESPs are used for the mesh network use the same frequency as Wi-Fi, but do not need to be under a Wi-Fi connection. So you could have a router over here, and they would extend the range of data transmission, even though it is out of the range of the Wi-Fi itself. Now, what are my sensor choices? I use the carbon monoxide sensor and also a heat sensor. Now, why not a smoke sensor? Well, a smoke sensor could continuously go off every time a possible fire is made indoors to cook food, or a propane stove is used. So I used a carbon monoxide sensor that is used to identify and is more sensitive to smoldering fires or starting fires. And also, if I need to compensate for the other side of the fact, I use the heat sensor that measures the difference in heat between now and about 2 minutes ago. So, for instance, when let's say you use the term shack, if a lot of people know that shacks do get hot in the summer. And how do you identify then if there is a fire or not? Because it is a high temperature. Therefore, I use a difference in heat between 2 minutes ago And if the house would catch fire, a difference in heat from 2 minutes ago would thus be seen. If it is a quick fire, thus the two sensors complement each other and also compensate for the not using the smoke sensor. And also something to note, just because there is a carbon monoxide sensor itself, it would also complement, it will also compensate for the fact that I wouldn't have killed myself very likely, and a warning would have given out if there is a possibility of carbon monoxide poisoning, not only just fires. Now here's my rough design sketch. Here are some nodes that I used, that I drew with the MQ7 and the heat sensors, and as you can see, they all can transmit to each other. Now the gateway I will talk about in a little bit. Here's my real model. The node is an ESP set up with the sensors for reading the values, and they would thus be spread all across each house. And the gateways act as data transmission lines, where, for instance, if you need the data within the mesh, then you would use the gateway, and the gateway would act as a bridge for the cloud, or for any method you choose to receive your data, where it could receive everything across the mesh without needing to plug your laptop into every node and try to get the data. Now here's my testing. I will show you an example in a moment, but as you can see, I have a fire over here, and in this screen it is hard to see, but it is giving the sensor values through. So the screen is there just to show that the gateway is receiving data. The gateway is in JSON, so it is in JSON code. So it is easier to translate that code into a bigger platform where you would essentially you could essentially make an app for it and have the data easier transmitted than just simple numbers and words. Now here's my Y schematic with the ESP set up and the MQ7 sensor and the DHT22. These resistors are there because the MQ7 and the DHT22 are both 5 volt native, but the ESP is 3.3 volt native, and therefore a voltage divider is needed to get the voltage from 5 volts down, the voltage signal from 5 volts down to 3.3 volts, so the ESP could understand it without blowing up the ESP itself. Now here's my gateway with an ESP, a screen and a buzzer that is unfortunately at the moment inactive. Now here's my code, an example. Now here are examples of functions that is needed to keep the mesh functioning. Now it does notify you when there is a new connection, when there is a changed connection, meaning something disconnected or reconnected in itself. It does initialize the mesh connection, and also it adjusts the time. So all nodes have the same clock. Let's say, yeah, just keeping the time at the same moment. Now I do have identifiers here that does detect the type of warning. If it is picked up by the gas sensor itself, it does say that it is a gas warning, and if it's picked up by the heat sensor itself, it is picked up as a fire warning. Now for my difficulties, power supply was a difficulty because the MQ7 itself uses a heater to identify if there is gas in between and the amount of gas in between it, and it is very power hungry, and thus sensor power consumption would be a difficulty because using a battery for this would not be good. Ideally you would want sensors that have a battery life about 2 to 5 years. So you don't have to say replace the batteries every week and thus replace hundreds of nodes and spending a lot of money on battery power. Now, power supply was also a big thing for the gateway itself, because adding solar panels to places in poor areas could also lead to theft, and thus they would also need to be on a battery or a different power supply. Power saving modes are like the deep sleep function in ESPs itself was also something I looked into and something I could get functioning, but at the moment it is taken off out of the code for the sake of the demonstration. And what the power saving modes do is they essentially take the Wi-Fi capability away for around, say, 10 seconds. It is configurable, and it would be able to read the sensors as well. And thus, if a fire warning is done, every 15 seconds, say, the ESP would then reconnect to the internet, and if a fire warning was done in the amount of time, it could also reset. So thus it would have high power consumption for a few seconds, low power consumption for a few seconds, and keep the battery alive a little bit longer. Now, there are two mesh libraries in the ESP examples. Now, ESP Now is a mesh library that is very common, but in the end, it felt difficult to do, and thus I used painless mesh, which was brilliantly named because it was painless. Yeah, I guess it was more painless than ESP Now, but yeah, some configuration was taken away from me, so also a future improvement would thus be using ESP Now. Successes: there is communication between nodes, so thus I would have communication. The sensing of carbon monoxide was done and the threshold was met. A warning was given through. It is capable of sensing a heat difference between now and 2 minutes ago, and getting data in JSON is also a success because it leaves me open to be able to use more things in the fourth term, as if I create an app it would be easier for me to use it thus because it is in JSON itself. Future improvements, like I said, using ESP Now is an optimal configuration. Using alarms on the nodes itself, because if a fire risk is met or a gas risk is met, you would want to notify the people inside the house that are in danger. So an alarm would go off, but also an alarm in the houses next to it who are also in danger. So an alarm would go off when your neighbor's house is ideally burning down. And having a gateway connected to the internet, thus being able for the fire department to really know if there is an actual fire. And using more efficient sensors, because using the MQ7 itself really makes my choice of having to deal with the power supply very, very difficult. Now, lessons learned. Spelling is important, as you can see the little meme over here. Software development, I can fix this. Crisis of confidence. Career, questions career, questions life, and then you figure out, oh, it was just a typo. Understand what you want and how you would want to accomplish it before you actually try and do it. Because if you find problems, then it's very stressful and very confusing. But if you don't understand what the problem itself is, you're gonna do yourself in a lot more than actually taking the time and understanding what you are doing. Now, being prepared for things not to go to plan. I got a big example for this when the MQ7 took a lot of current and practically pulled the rug under my battery-powered idea. Soldering is fun when you're not touching the iron with your fingers, and make sure it's doable before making promises. Because standing in a panel here and making promises is something, but if you don't understand what you are doing and how you accomplish it, making promises and now, and on the other end, not doing that would thus be not cool. Now, here's my bill of materials, and this is my total cost, which is the node itself and the gateway combined, which it comes to 728 Rand. The nodes cost 764 Rand, so this would be spread across a whole community, and the gateways costing 444 Rand, would, let's say for a whole community, only ideally 3 for redundancy would be needed. If one gateway is shut off or out of power, then you would have 2 more where you could essentially take the data from. Now here are my references. This is the article at the top of the carbon monoxide poisoning causing the deaths of 21 young people. And there's an article showing the problem of how fires in informal settlements are a big risk, and how they can quickly turn into large-scale fires, causing loss mass of life and also property. And this is an article of the government implementing smoke sensors into informal areas, but it is unfortunately very vague on what they exactly did. Now my work distribution, the designing, researching, building, testing and also stressing was 70% done by me, and electrical coding, troubleshooting and helping me with basically any problem I had was 30% done by Nick. This is my activity log. As you can see, a lot of time spent on theory because we did cover electrical and a new coding language at the same term. Relatively a lot spent time on a design project, a tutorial project also. 3.3% was spent on extra time working at home, doing anything I needed for this course. And acknowledgements, thank you for Nick for helping me doing 30% of the work, helping me getting troubleshooting issues and all that. And thank you for Urendal and Tanit Almari for giving me a lift back to town when I forgot my design project at home. And thank you. I will now show you a demonstration and the questions will be after that.